So last time where we left off, we were doing a little bit of testing on the, just basically trying out this for the first time, that flexible coupling there. And in the process, a bearing noise turned up. And I decided it'd be better to stop and investigate that further. And what I thought it was that pillow block bearing back there, and we'll have a look at that here. Yeah, so the bearing that I thought was making the noise, I thought it was this one. I thought that because the noise sounded a lot like the noise I was getting before, and I replaced the rear pillow block bearing, and I was good for a while. But what it's shaping up to be is that it's the bearing that's inside of here. What we're going to have to do, I'm going to have to take this all back apart again, and we're going to actually take the absorber off of here and disassemble it, inspect the bearings, and replace them, and we're going to do a few other things along the way too. And I thought the other thing about this is that it gives people an opportunity to see what's inside of this. And there has been a little bit, not a lot of interest in that, but a little bit. So when we take it apart to replace the bearings, we can have a look inside of this. And the other thing I think I ought to do while I've got it apart is balance that rotor in there. At any rate, that needs to be done. The bearings need to be replaced, and there's going to be something else I noticed about the bearings here. At any rate, let me start taking this apart, get the absorber out of here, start taking it apart, and kind of see where we're standing with this. And hopefully it's something that isn't going to be too bad to fix. Okay, so I've got the absorber off of the stand in there, and I've got it partially disassembled. And like I said, I wanted to show a little bit about what the inside of the absorber looks like. And, you know, some of the downsides to the way I chose to build this thing. And I used steel. This is mostly steel here. Actually, it's all steel here. And, well, it's mostly steel. Some pieces are made out of cast iron, but it's mostly steel here. And we'll take a closer look at the rotor when I get it out. But I just kind of wanted you to see how it sits in there. And what it does is this piece here, you flip it over and it slides down here, and what happens is the water comes in through here and then into this section. Once the water goes in here, this piece is spinning, and then what it does is it throws the water out to the side, to the outside of it, where it gets caught in the stator, and it stops it. And then it kind of keeps going through this cycle, and I think it's called toroidal flow. I don't know how much of that I'm getting in my design, but the idea is that the water goes back and forth between the rotor and the stator, where it gets accelerated and decelerated, which essentially is stirring it. When the water is stirred like that, it heats the water up, and that's where the energy coming out of the crankshaft goes. It goes into heating up that water. This the stator here has 10 fins in it, and the rotor actually has 11. What I read in a SAE paper is that either the rotor or the stator should have a prime number of fins, and last time I checked, 11's a prime number, so I have 11 on the rotor and 10 on the stator. What would possibly happen is if you had 10 fins on the rotor and 10 fins on the stator, it would there'd be a tendency for it to make a vibration from them matching as they go across there. And then there is a seal here, and I've never been real happy with the way that seal worked, but it does. The idea there is to try to keep the water that's in here from getting into the bearings. The shaft here has a keyway in it. What I did there was I basically got a repair sleeve for one of these shafts right there, and I machined a keyway here in another piece of this here, and then the idea was to make the outside of it round, and then I put this repair sleeve over top of it, and then I put this washer on top of it. So the idea is that the repair sleeve covers up this gap, because without that, the water would just flow right through and get into the bearings, and that is what happened to me previously. So this set of bearings I have to put on today are going to be the third set of bearings of these bearings that I've installed. This shaft here is turned, ground, and polished, so I didn't set the diameter of that. That was just the way I bought it. And the bearings were made for this shaft, so they go on there, they slide on. And what I'm kind of seeing here, right there, you can see how the inner race of the bearing is sliding on this surface, which isn't ideal. And I'm a little bit worried that maybe that's wearing that down there over time. And if it does wear that out, the only real solution there would be either to have this welded up, which I don't think would be, that repairing this wouldn't be worth it. What I'd have to do is replace this entire shaft, which can be done. But for now, that doesn't look terrible enough to me to really warrant worrying about it. Most of that's happening there because that inner race is allowed to slide on there, so the inner race has a little bit of clearance between the bearing inner diameter and the outer diameter of this shaft. So that's another little something about my design here that I don't particularly like that much. Now that you can kind of see what's in here, if you have any questions about it, just go ahead and ask me in the comments. So anyway, let me get this out of here and we can have a closer look at that. And then with that, with the rotor out of there, I just wanted to, you can see that this side of it is basically the same as the other side of it. This absorber has stators on both sides. Here's a look at the rotor with it out of the housing. See it on that angle. Let's talk about some other issues that I see. And again, we have this problem here where the inner race is actually sliding on this surface, which I don't like. Well, there might be some ways of me dealing with that, but we'll think about that. And I did it on both, but I don't believe that this business here is actually my problem. Let's look at something else real quick though. Okay, so this is the bearing that was making the noise. And I'm going to try to make it so you can see it. So there's the outer race of the bearing, and this is the inner race. And I could see before how the shaft was spinning inside of that, which isn't ideal. And then the other thing I'm seeing is that the outer race, I think you can see that there, can't you? Put a mark there so you can see it. You see how that's moving around in there, and that's not supposed to, I don't want that doing that either. Because what's kind of happening, what I think is happening, rather than the bearing doing its job and this holding still and this being fixed to the shaft, this is sliding, the shaft sliding in here, and this bearing is also sliding around inside of that housing. So it's almost like the bearing, it's almost like these surfaces here and here are acting like the bearing, and that's not what I want. I want the bearing to do its job. And I noticed the other thing about this is that it tended to do the noise when it wasn't under a load. And I think it wasn't doing it under a load because when you put a load on it, it puts more, what would that be, radial thrust on this, and it forces that down that way, and then it holds this to the shaft and it holds this to the housing, and then the bearing actually starts doing what it's supposed to instead of this whole thing spinning around in here. And I think my guess is that's probably what's making the noise. Here's my solution to that, is that I think when I put the new bearings in, I'm going to clean this really good and degrease it, and then we can, I think I'll put a little bit of Loctite around there, a little bit. Now the problem with that is if I ever want to take the next bearing out, you know, that's going to make it more difficult. And there's a possibility I might put some Loctite in between here, but if I glue this in place too good, taking it apart could become a very, very difficult thing. What I'm going to do next is I'm going to get these bearings out of here. This one here, I'm going to take that seal off of there, and I want to see what's inside of there and see if there's anything maybe that contributed to this problem. I think that bearing's actually okay. I think it's the clearance between here and the housing, and possibly that and the clearance between here and the shaft. So I think I'm going to correct this outer clearance problem by applying Loctite in that area before I reassemble it, and maybe put a little bit inside of here. I haven't decided on that though yet. So well, we'll see how that goes. But yeah, I am going to replace the bearings anyway, but now that we got that done, there's one other thing I want to do while I have this apart. So the last thing I want to do before I put this back together is I want to do at least something to try to balance this thing, because I've never done anything to balance it. I have used this method before with success. This method wouldn't work normally because, well, It wouldn't have worked because I have this keyway here, but I made these sleeves to go on here to take care of that keyway problem. And these pieces here, there's one on both sides. They're both straight edges for like checking engine blocks and cylinder heads for straightness. So they're pretty flat and straight. Now the way I have this set up is not perfect, but I think it's probably going to do what I want it to do. But the idea is they're straight, and then the other thing I did was I used the machinist level to level these out so that they're flat. And that's what this thing needs to be, really flat, in order for what I'm going to do to work here. Because this part's rather simple, what's going to happen is the heaviest part of this is going to be on the bottom. So what we'll do is we'll look at it like this. And you can kind of see it rocking back and forth there. Wherever that settles down at, the very bottom part of that is going to be the heaviest part. Once it stops, I'm going to mark it there. Alright, so that seems like it's calmed down quite a bit. So now what I'm going to do is do my best to look at the opposite side of this, because the opposite side of this is going to be the heaviest part of it. So there's the mark I made right there. And what I'm going to do is I'm just going to remove the material off of that, probably using a drill. Okay, so here's the material that I removed off of this side to get that balance, I think, quite a lot better. It was more out of balance than I thought it was, so these go down about, I don't know, maybe that far. And kind of see how it's doing here. It's not perfect, but it's pretty darn close. I think a lot better than it was before. I think I can work with this. Kind of see, but you know, the other thing of it is like I might be at the limit of the accuracy I can get in terms of the balance based on the way I'm doing this. I think the really way to get it just perfect would be to take it to a machine shop and maybe have them balance it the way they balance, you know, using the machine that they use to balance crankshafts. I think I'm kind of at the limit of what I can do with this type of a balancing operation. I think it looks pretty good. Anyway, that's where I'm going to leave it. I think that's where I'm going to leave it. Because like I say, it does something different depending on where it's slightly different depending on where it is on these. So I think that's the best I can do with the tools that I've got here, and I'm willing to try this out. So to wrap this video up, I don't think you need to see me put it back together. I think what you need to know is that I made an attempt to balance this. I think that the noise it was making was a result of that bearing being loose inside of that housing, and the way I'm going to correct that is by putting a little bit of Loctite in between the bearing and the housing, and maybe between the bearing and the shaft. So that's where I'm going to leave it. Well, yeah, that's about the best I can do with these tools. So I guess that's about all I got for this week, and we'll see you next time.